Dmitry Mendeleev was a Russian chemist and inventor, and back in the mid-19th century, he devised the periodic table, which organized all of the known elements. In fact, when he made it, it even predicted new elements that we hadn't discovered yet. As we saw in our video on elements, everything in the universe is created from different combinations of the elements in this table. Just like a book, it's read from left to right and from top to bottom, with the elements arranged in order of increasing atomic number, which represents the number of protons in the atoms of that element. Within each of these boxes is the nuclear symbol for that element, which has three components. On the right, we have the elemental symbol, which is the one or two letter symbol for that element, in this case Na, which stands for sodium. In the bottom left, we have the atomic number, which tells us how many protons the atoms of that element have. And in the top left, we have the mass number, which tells us the total number of protons and neutrons in that atom. While he was organizing the table, Mendeleev found that the elements displayed a pattern of chemical properties that repeated at regular intervals. So instead of arranging the elements in one long line, he formed a new row every time the pattern repeated, which we now call periods. Because the patterns repeat with each new period, the elements in each vertical column have similar chemical properties, and we call each of these columns a group, starting with 1 on the far left and going to 7. So here we're looking at group 2. There are a couple of exceptions to this though. One is that the far right group is called group 0 rather than group 8, and we'll take a closer look at why this is in a minute. The other is that the block of metals between group 2 and 3 don't have group numbers. Don't worry about this for now though, just remember to ignore them when counting your groups. The reason that elements in each group have similar chemical properties is that they have the same number of electrons in their outermost shell. And this is largely what determines how an element reacts. In fact, the group number actually tells you exactly how many electrons they have in their outer shell. So as we're looking at group 2, we know that every element in this group has 2 electrons in its outermost shell. Just make sure you don't get confused here. All of the elements in a given group have different total numbers of electrons. They just have the same number of electrons in their outermost shell. So if we move over to the group 1 elements, which we call alkali metals, we can tell that they all have 1 electron in the outer shell, whether it's lithium, which has 3 electrons overall, or sodium, which has 11 electrons overall. And it's this feature that gives all group 1 elements similar properties. For example, they all react violently with water. There are also trends within groups. For example, the group 1 elements become more reactive as you go down the group, as we'll see later in a video specifically on group 1 elements. Group 7 elements, meanwhile, which we call halogens, all have 7 electrons in their outer shell, although these elements become less reactive as you go down the group. As we said before, group 0 is a bit different. These elements are called the noble gases, and they all have full outer shells. So argon, which has 3 shells, has 8 out of 8 in its outer shell, while helium, which only has 1 shell, has 2 out of 2. Because if you remember, the first shell can only hold up to 2 electrons. Because they don't need to gain or lose any electrons, the noble gases are all very unreactive. Sometimes you might see a zigzag line running here, from aluminium to polonium. This line separates the metals, which include everything to the left in orange, from the non-metals on the right, still in blue. So as you can see, there are lots more metals than there are non-metals. And in the middle of the metals, there's a special block of elements, which are known as transition metals. We'll take a closer look at what these are in another video, just like we'll take a closer look at the group 1, group 7 and group 0 elements, and the differences between metals and non-metals. Before we finish, we just wanted to point out that if you Google periodic table, you'll probably see loads of different types. For example, you might find that the position of the mass and atomic numbers has been reversed. like the example of iron here. Don't worry about any of this though, the tables all show the same information, just presented in a slightly different way. And you can always tell which is the atomic number, because it will be the smaller of the two. And in your exam, the periodic table you'll get given will be similar to the one we've been using throughout the video. That's it for now though. If you enjoyed it, then please give us a like and subscribe, and we'll see you next time.